Hello, my name is Ben Griffiths, and today I'm going to be talking all about how we might be able to improve memory using imperceptible sensory stimulation. So lots of past work has shown that gamma oscillations correlate with a successful retrieval of episodic memories, but we don't know whether these gamma oscillations are a cause or a consequence of the retrieval process. So to address this, we use sensory stimulation, where we take a light and we rhythmically fluctuate it at our gamma oscillations of 65 Hz, with the idea of enhancing endogenous oscillations. When we do this, we expect it's going to enhance episodic memory compared to conditions where we flicker a light, either at a slower rate or not at all, where we don't really expect any modulation of endogenous oscillations to happen and therefore no influence on memory to be observed. We did this all in a traditional episodic memory task where participants saw pairs of videos and words and then later had to recall the video when given the word. Jumping straight to results, what we found is, relative to a baseline condition where no flicker was presented, 65 Hz are gamma oscillation and 32.5 Hz, so that's a subharmonic of a gamma oscillation, saw significant improvements in memory relative to the baseline. This was specific to retrieval, which were cutter plots, and we found no effect at 43.3 Hz either, suggesting it's not a general effect of flickers enhancing memory. Importantly, participants couldn't perceive the stimulation when it was presented at 65 Hz. So in a task where participants had to just report whether they could see a flickering screen, while they could do it for the slower frequencies, they couldn't observe the 65 Hz effect, suggesting this intervention, memory-enhancing intervention, is imperceivable. We went on and replicated this entire experiment in a second sample, and again we found our effect where 65 Hz seems to really enhance memory performance, specifically for retrieval. To understand why these effects came about, we built a computational model which generates endogenous gamma oscillations and then hit these gamma oscillations with an external drive to mimic the sensory stimulation. What we find is the model itself builds a nice little 60 Hz gamma oscillation, and when we hit it with 60 Hz or 30 Hz stimulation, we really enhance these oscillations and the neural coherence between single units. Critically, we are able to find a similar pattern of results where the 30 Hz and the 60 Hz strongly enhance coherence relative to baseline, and the 40 Hz or 45 Hz does not. All sort of replicating our behavioral effects reported up here, suggesting that the sensory stimulation enhances memory by enhancing neuronal coherence. So in summary, 65 Hz sensory stimulation seems to act as an imperceptible intervention to enhance episodic memory. Computational models suggest this is due to the fact that the entrainment enhances an endogenous gamma oscillation and helps enhance neuronal coherence. However, future work is still needed to identify where this oscillation is within the brain, and also to explain why we don't see similar effects at encoding and what particular process the stimulation is enhancing.